Welcome to Vision Plus and welcome back to this senior for mathematics on complex numbers. We are now doing the Argand diagram and we are on example 4. Example 4 says that we are given three complex numbers Z1, Z2 and Z3. And then we say that we need to represent each of the following on the Argand diagram. We have part A, part B and part C. So for part A, Z1 is given as 1 out of 4 minus 2i. The first step that you need to do when you are drawing an Argand diagram is to draw a complex plane, and that carries a mark. The complex plane has two axes, that's the vertical axis and the horizontal axis. The horizontal axis is what we are calling the real axis, and the vertical axis is what we are calling the imaginary axis. Now this is the complex plane, and then you come back and look at the numbers that you are supposed to represent. We have here the real part, which is 1 out of 4, and the imaginary part, which is negative 2. Now if you look at this here, we have a fraction. The simplest way that you can represent a complex number on the Argand diagram when they are fraction is, you just need to locate that number alone. Okay, like here on the real axis, we are supposed to locate 1 out of 4. It is positive. Now also on the imaginary axis, we are supposed to locate negative 2. Between 1 out of 4 and negative 2, which one is bigger in magnitude? It is 2. And 1 out of 4 is smaller in magnitude because 1 out of 4 is simply 0.25. Here, do not stress yourself to get a perfect scale. No, we don't represent it perfectly. So what do we do? On the real axis, we just need to locate 1 out of 4. So you can just come and say somewhere here, this is 1 out of 4. It's straight away. You don't need to indicate maybe 1, 2, 3, 4. That will make your work very hard. Having located here 1 over 4, then you come and also locate the corresponding negative value on this side. The same distance from here is the same distance from here up to here approximately. This is negative 1 out of 4. Now you have represented the real part on the real axis of the complex plane. And then you come to the imaginary part. It is negative 2. Now, we have said that negative 2 in magnitude is bigger than 1 out of 4. That means its distance from the origin, this is the origin, its distance from the origin should be approximately further away. Approximately further away. Let me just say this is negative 2. The distance from here up to here should be bigger than the distance from here up to there. Why? Because 1 out of 4 is smaller than 2. And then you come and mark the corresponding value on the positive part of imaginary axis here too. It was negative 2. We have indicated it down here. It is negative 2. This is how you represent complex numbers on the Argand diagram when they are fractions or decimal numbers that you cannot easily approximate to scale. Now, from here now you are done. On the real axis, you have 1 out of 4, which is here. On the imaginary axis, you have negative 2, which is here. So what do? You just come and get where they're coming to meet. Let's get the point of intersection, approximately somewhere here. And then you come and mark it there. And then with your ruler, you get a straight line from the origin to this point of intersection. My ruler is not here right now, but for you, you must use a ruler. Straight line up to there. Then you put an arrow on top because we are saying that it is a vector quantity. And then you just say this is my Z1. And this is the solution to example 4 of part A. Then going to part B. Part B says that the complex number Z2 is given as 2 out of 3 I plus 5. What is the first step here? The first step always is you drawing the complex plane. This is the complex plane. This is the imaginary axis, which you must label that, and then this is the real axis. The same, you come and look at this number. You have 2 out of 3 and 5. 2 out of 3 is on the vertical axis because it is containing I. It is on the imaginary axis. So what do? Just come and label anywhere you want. Approximately, maybe somewhere. You say this is my 2 out of 3. That means corresponding down here is negative 2 out of 3. This is the origin. How about on the real axis? Here we have 5. Now, between 2 out of 3 and 5, which one is bigger? 5 is bigger in magnitude. So, 5 should be further away from the origin. This is the origin. 5 should be very far away from the origin. This is positive 5. This is negative 5. What is the next step now? You have drawn your complex plane and even you have labeled the values on the axis. Now you come to your complex number. We have 2 out of 3, which is on the vertical axis, which is here, positive, and then 5 is also positive. So you just dot it here so that you get the point of intersection. So they're meeting somewhere there. And then you draw a straight line from the origin up to that point with an arrow at the top. And that is the complex number Z2. This is the complex number Z2. Try to use a ruler so that you have a straight line. Don't have my ruler right now. Then for part C says that we are given Z3 as 6 plus a half I. You go on and you do your complex plane. This is the real axis, and then this is the imaginary axis. This is the origin 0. Then you come and look at the numbers. Here we have 6 on the real axis, and then we have a half on the vertical axis. What do you do here? On the vertical axis, we have a half. So let me just say this is where my half is. That means correspondingly, we shall have here negative a half. Between 6 and a half, which one is bigger in magnitude? It is 6. That means 6 should be very far away from the origin. Maybe somewhere here. That means negative 6 will be somewhere there. This is negative 6. This is positive 6. Our drawing is not to scale. It is just a reasonable representation. Now, on the vertical axis, we have a half, which is here, because it is positive. And then we have 6, which is here, which is also positive. So just come and look for where that can be the 6. Somewhere there. Let me draw. Use a ruler, draw a straight line from the origin up to that point. Then indicate that this is my Z3. So this is the solution to example 4. And thank you. Let us go to example 5.